few things. So first thing first, if you are having, suppose you are having x is smaller than 7, okay, we can represent it on number line. We can say if x is smaller than 7, then on number line somewhere 7 is there, and x is smaller than that. That means x will, this is the, okay, this will be the representation, or this will be the graphical representation for the same, that x is smaller than 7. That means towards the left side of 7 we can take any value, but not the right. Getting it, Manvi?
Yeah.
One more thing, whenever here just smaller than is there, then we will be taking a hollow circle. Okay, this hollow circle represent that we are not touching 7. We are not touching 7. Okay, we are taking all the numbers towards the left direction of 7, but not 7. Okay, if our inequality will look like this, x is smaller than or equals to, just a moment. If our inequality is x is smaller than or equals to 7, then we will be taking that from 7, okay, everything from 7, and here we will be taking a solid circle. That means we are touching 7 also. X can be 7 also. Making sense?
Yeah, it is.
Okay, these things you will be learning in detail in inequality chapter. That first find the solution, then represent it graphically. But now only I'm telling you, for the very first time you are seeing this thing, and don't worry. Okay, this is really simple. Hollow circle means we are not touching 7. That means the previous one, x value can be anything is smaller than 7. Maybe x can be, okay, x can be 6, x can be 5, x can be 4, x can be 3, x can be 2, x can be 1, x can be 0, x can be negative numbers as well, but not 7, so hollow circle. And here x can be 7, x can be 6 as well, it can be 5, it can be 4, it can be any number which is a small 7 or is smaller than 7. Got it? Now the next one is bigger than, the larger than situation. When we are having, suppose the same thing, x is larger than 8. That means if I will be representing it on number line, this is inequality. Actually, it is inequality. Okay, whenever we are having equality sign like x equals to 5, this is equation. Okay, this is equation, and that's called inequality, where you will be having greater than, smaller than, greater equals to, smaller equals to. Okay, that's called inequality. So we are dealing, I'm just showing you how to represent our inequality in the, on the number line. So x bigger than 8, we are having somewhere 8 will be there on the number line, somewhere 8 will be there. See, I'm not just writing all the numbers 0, 1, 2, 3, then minus 1. Yeah, you can do that as well, but I'm just trying to show you that somewhere 8 will be there. Okay, and we have to take bigger than 8, so towards the right direction of 8, right, Manvi?
Yes, ma'am.
Okay, again equality sign is not there, so hollow circle, that we are not touching 8. We are not touching it in inequality chapter. Only this one will be given, only this one. And then from here you will be declaring that your x is bigger than 8. Okay, hollow circle means equal sign will not be there. Okay, so yeah, here also we need these things here and there. That's why quick I'm just trying to clear it now. Similarly, if we are having x greater than or equals to 8, x bigger than or equals to 8, same thing we will be doing from 8 greater than, but equal also there, so solid circle or solid circle, which is representing that x is touching 8 as well. Now these are the four ways to represent these solution. Now I want to say over here that when you are having inequality, that is x maybe bigger than 4, and x is bigger than 4, and x is, let's say, if I am saying the x is smaller than, okay, minus 4. So if we will be representing this two on the same number line, somewhere 4 is there. X is bigger than 4 means bigger than 4. Okay, only this one first I am representing. Okay, equality sign is not there, hollow circle. Is it making sense, Manvi?
Yes, ma'am.
X is smaller than minus 4. So X is minus 4 is smaller than that. That means towards the left. Towards the left. Okay, again equality sign is not there, hollow circle. Now here if I will write or no, here if I'll write or, then your solution will be this region also and this region also. Both are your solution.
Yeah.
Okay, and here only if I will write and, okay, if I will write and over here, then you will say there is no common solution. So actually I wanted to say initially that and means no common, like just we are checking the common part. For example, okay, there is no common solution. And means we will only be taking the common solution, and or means we will be taking everything. This also, that also, both are there in the solution. The final solution will be this one also, that one also. Or means this also, that also. Okay, and means only the common solution. Okay, so let me show you how exactly your common solution will look like. Suppose you are having an inequality, x is bigger than 8, another is x is bigger than 6. So let me represent it. X is bigger than 8, x is bigger than 6. Okay, somewhere we are having 6, somewhere we are having 8. X is bigger than 8 will be this one, right, Manvi?
Yes, ma'am.
Okay, a hollow circle. And x is bigger than 6 will be this one. Okay, a hollow circle. Now, when and will be there in between, okay, x is bigger than 8 and x is bigger than 6, then you have to take the common solution. And are you able to visualize that this is the common reason? Wait. No, not this one. I mean this one. Where the black one is also going and the blue one is also going. Can you see that?
Yes, ma'am.
Okay, this is the common solution. So whenever this and will be there, no, okay, we will be taking the common solution and or just the common. So the resultant of this two, the final answer, the final answer will be x, okay, bigger than 8. Clear?
Yes, ma'am.
Okay, now let's start the discussion. Sets we were discussing. Here we will encounter this type of situation. So we were discussing sets, and here the next part is empty set. Last class only we were discussing. Yes.
Ma'am, if like these questions where you have to graphically represent it, will it in the question will it mention if the answer is negative or positive?
Negative or positive, it depends. See, I'm talking about this type of scenario. Okay, you have already learned this chapter, little bit idea you are having. So I want to show you this question. Can you see question number 3, Manvi?
Yeah.
X is smaller than 5 and x is bigger than 7. And is there. Okay, I could have taken the same question and quick, I could have explained that this is not making sense, or maybe this is making sense. Yeah, it will be empty, or maybe it will not be empty. Okay, directly I could have told you, but this much brief I have given you that in case you will encounter or, then you will understand that what is the difference between and or. So if x is smaller than 5, let me represent it. Okay, on number line first we'll be having 5, then we'll be having 7, right?
Yes.
Okay, x is smaller than 5. That means towards the left of 5, like this. See, you don't have to represent it graphically. Here it will not demand. The question is not demanding from you that represent it graphically. Okay, but we
Okay.
are doing it. Inequality chapter, there you will be doing these things. So here you are just doing for your clarity. X is smaller than 6. 5 means this one. And x is bigger than 7 means this one, right? Both hollow circle. Now,
Yeah.
and is there? Is there any common solution? No. And means we have to only take the common one. And is there any common? No. Is that possible that any number is smaller than 5 and also bigger than 7? No. Okay. So and means common region. Here we don't have common region. Either you understand this way or you just understand this way, that there is no number which can be smaller than 5 and at the same time bigger than 7. Okay. Hence,
Okay.
hence this one is empty set. In this set, we won't be having any number. This is null set. We represent it like this or we represent it by using 5. Right, Manvi?
Yes. Ma'am, for one of my exams, like my previous exams, I had a question like, how do you represent empty set? And it gave this bracket and it also gave the symbol. But I put bracket and I got the question wrong.
Okay, this bracket was also given, just the empty set.
Yeah. Yeah, both of them.
Okay, both of them was there. Yeah, we
Yeah.
represent this two way. Okay, we write empty set by this way, or maybe we write it by using the phi. Okay, so I need to check what exactly is the statement in the question. Can you see the statement one more time? Maybe the statement is quite different, that by which symbol we represent or something like that was there. Please check.
uh, I'm not sure.
According to this definition, B is an empty set, A is not empty. The empty set is denoted by this two symbol. Okay, if I can zoom it for you. I need to check the statement, Manvi.
Yeah.
Okay, there are two ways to represent the empty set. And the whole thing which I was explaining you for now, just because sometime you can have x is okay is smaller than 5 or x is bigger than 7, that time please don't say this is empty set, because or is there. Okay, so we don't need the common solution.
Okay.
Getting it?
Yeah, yeah.
Okay, so yeah, you just need to be clear with this too. The graphing and all you don't have to do. Now here one by one we will be checking whether the sets are empty set or not. Empty set discussion last class only we have started, but we have not done any question. Okay, today we can discuss questions from here. Then finite set, infinite set. Okay, the types of set. So finite set, see the name is saying all about itself. Okay, finite set. If I will write the set of all vowels, finite, a e i o u. Okay, finite, a e i o u. Okay, set of all consonant. Okay, it will be finite set. Okay, b c d, all the remaining alphabet, but it will be still so many alphabets you will be having over here, but still it is finite, right, Manvi?
Yes.
Okay, but if I will say the set of natural number, that is infinite. Set of natural number is infinite because we don't have any limit for natural number. It is starts from 1 but keep on going and keep on going and keep on going and keep on going. That's infinite set, right, Manvi?
Yes.
So this way we will just the name finite or infinite, just the name is saying all about itself. So accordingly we will be analyzing the finite set or maybe the infinite set. So first we'll be doing the first part, which is really simple. Just identify whether the given sets are empty or not. Okay, empty set we also call it null set. Okay, null set.
Ma'am, is there a symbol for infinity set?
Infinity, infinity we use this symbol in mathematics. Okay, we use this symbol. Actually, our number line, no, for the very first time you are seeing this symbol. So on number line we are having, see, this is the number line. Here you are having 0. Here you are having positive 1. Here you are having positive 2. Here you are having negative 1. Here you are having negative 2. Actually, this is going on, going on, going on in this direction, in this direction. And at last we say that here we are having minus infinity and here we are having plus infinity. Okay, so till class 10, you have never seen this symbol. Okay, but now, yeah, we call it infinity. That it is just keep on going and keep on going and keep on going and keep on going. That is infinity, and we are not able to touch this infinity. Okay, this is not a real number. Infinity is not a real number. Manvi,
Yeah.
infinity is something which we can never ever touch. Okay, it's just like a ocean, that it's just infinite and we are not able to see the limit. Okay, so infinity is not a real number. We, on the number line, it goes minus infinity to plus infinity, but these two are not real number. Okay, and one more thing, in class 10 you must have learned that 1 by 0, that is, okay, not defined, right?
Yes, ma'am.
Okay, from now onward, we are going to call that this is only infinity. What about 2 by 0? That is also infinity. What about 3 by 0? That is also infinity. Okay, so
Okay.
0 in the denominator, which we were calling till now, that it is not defined. Now we'll be saying this is infinity. Getting it?
Yes.
Okay. So yeah, quick. We'll be having the questions over here, which is from empty set. Okay, we will just be reading the statement and we will see if any element will come in our set or not. For example, the example which we did just now, x is smaller than 5 and x is bigger than 7. Okay, if you, even without having understanding of these things, okay, the number line and the graphical part, if you will just think that, you will not find any element which will lie in your set and hence empty set. Okay, and the question which you are talking about, Manvi, please show me that particular question, with this statement. Okay, so that I can see what exactly was the statement.
Yeah,
Then
actually, it was a test in school, like a small test. So, ma'am had presented the questions. I don't have the question.
okay, she has presented, no worries. Okay, I'll see that what can be the possible statements. Okay, so yeah, so first let's cover it quickly. The first one is set of odd natural number divisible by 2. Okay, odd natural number starts from 1. And if we have to talk about odd natural number, it will be 1, 3, right? Manvi?
Yeah,
Okay, 1, 3, 5, okay, 7. These are odd natural number. Divisible by 2. If we are talking about odd number, we
it's a
cannot say
null.
this is divisible by 2, right?
Yeah, it's null set.
Yeah, it is null. Perfect. Set of even prime number. Does that exist?
Yes.
Okay, even prime number. Can you tell me here only, Manvi, that is finite or infinite set?
Um, which one?
Set of even prime number.
It's infinite.
It's infinite. Okay. So many even prime numbers we can have. Next, next one.
That's not a null set.
Yeah. The third one. X says that X is a natural number. What you said, Manvi?
It's not a null set, it's 6.
Yeah. Okay, it's not a null set. Next one, we are having Y says that Y is the next one already we have discussed. X is smaller than 5 and X is bigger than 7. Null set. Okay. Fourth one, set of all Y says that Y is a point common to any two parallel line.
Is it infinity?
Okay, two parallel line means, okay, I can say line L and line M are parallel with each other, right?
Yeah.
Okay, and in this two parallel line, the distance between this two parallel line will always be same. It will never ever meet, right?
Yeah.
Okay, that's called parallel line. Now the question is there any common point of intersection L and M? Is there any point of intersection? No. Okay, a big no. There is no point of intersection. These two are parallel with each other, right?
Yeah.
Okay, now
Oh,
let's see what the statement says. We have to create set of all y such that y is a point common, okay, common to any two parallel line. Any two parallel line has a common point. Is that possible?
no.
No. Okay, you cannot have a common point. What is common point? Common point is, suppose you are having a line, maybe P, and you are having a line Q. Then both have a common point O. Can you see? O
No.
is sitting on the first line and the same O is sitting on the second line, hence common point. Getting it?
Yeah.
But parallel line cannot have any common point. Okay? So null
Mm.
set. When we are saying parallel, then parallel and common cannot exist parallelly. I mean,
Ma'am, so
cannot,
you can't like draw a line connecting them?
if we will connect them, then it will not be parallel.
Okay.
Parallel line are such two such line which will never ever meet. Never ever meet. Okay, here also the distance is 5 unit. 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 I will keep on extending beyond my screen, beyond my house, beyond this building. I will keep on extending till infinity, and still I will be finding the distance between two is 5. They will never ever meet and maintain the same distance. That's called parallel line. Getting it?
Yes.
Okay. If they will meet somehow in future, that's not parallel. Till infinity, that will not meet. If you will just keep on extending from the left direction or maybe from the right direction, it is never ever going to meet. That's the definition of parallel line given by our mathematician, that two such line which is never meet, which is going to never ever meet, okay, and will maintain the same distance, always, always. Till infinity, it will maintain the same distance. That's called parallel line. Okay, so we can say that common and parallel, these two are completely okay. It is invalid situation, it is null set. Got it?
Yes, ma'am.
Okay, let's do the next one. Finite or infinite set, these are two different types of set. Okay, the name is saying all about itself. Let's see. The first one, the set of months of a year. If you have to make the list of months, you will be able to make the list. Okay, and there will be finite element, right? Right,
Yes.
Manvi? Okay, next one, clearly you can see 1 2 3 and then dot dot dot, this dot dot dot, it's keep on going and going and going and going till infinity. Okay, so this is infinite. Can we say, Manvi?
Yes, ma'am.
Next one, 1 2 3 dot 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 9900. Even though the list is really big, but still it is finite. Okay, even though you are having, okay, like you are having 1000 element, 1 crore element, 2 crore element, 10 crore element, or more than that. Still, it is finite. Still, you are able to count them. Okay, infinite means you cannot count them. Next,
Okay.
so far, any doubt, Manvi?
No.
Next, the set of positive integer greater than 100.
Infinite.
Yeah, because you will be having positive integer after 100, 101, 102, 103, 104, 105, 106. Till which number we don't know. It will keep on going and keep on going and keep on going and keep on going. Okay, this is infinite set. Set of prime number less than 99. Okay, prime number, recall Manvi. Once you started learning prime number, composite number, maybe you were in class 2 or 3, right?
Yeah.
Okay, and that time you were not having idea of integers, right?
Yeah.
Okay, so prime numbers, you realize that numbers can be even number, numbers can be odd number can be natural number, or numbers can also be prime numbers. Okay, integer
Yeah.
still we don't know. Still, that time you were not having any idea about integer. Actually, when we have to think about prime number, we take the numbers from 1, 2, 3. Okay, from here we see which number is prime number. Okay, which number is divisible by itself only. So 2 is prime, 3 is prime, and we have to take the set of all prime number less than 99. So prime number, composite number, we can check from 1. We cannot think about integers. Getting it?
Yeah.
If only prime is written, Manvi, you cannot think about integer. If it says prime integer, then you can think about the negative, positive, any number. Getting it?
Yeah.
Okay, so just prime number means number in class 10 also. Your first chapter started with the same. Okay, prime number, composite number. 1 is neither prime nor composite. 2 is the smallest prime number, right?
Yeah.
Okay, so we have to create the set of all prime number less than 99. So we'll be able to make the list of all number. Okay, which is prime and less than 99, and this will be finite set. Are you getting the feel? Less than 99, it will be finite set.
Yeah. Understood.
Okay, this is finite. State whether the following set is finite or infinite. Let's have a discussion. So the set of line which are parallel to x-axis. Okay, set of line which are parallel to x-axis. Now parallel to x-axis, we can have so many lines. Manvi, parallel definition, just now we were discussing just a line which is maintaining same distance with x-axis. So that distance can be 2. Okay, or maybe that distance can be 8, or maybe that distance can be 5. 5, 5, 5, 5, 5. Another parallel line you can see I have drawn. I can draw so many parallel lines which will be parallel with x. Okay, another line which is maybe maintaining 10 centimeter, 10 centimeter, 10 centimeter. Just a line which is maintaining equal. Okay, always maintaining same distance with x-axis till infinity. Even if you will keep on stretching this line, keep on stretching it and keep on stretching it, it will keep on maintaining the same distance and will never try to coincide. Never ever try to coincide. That's called parallel line. Okay, and with x-axis you can draw any number of parallel line by maintaining the distance as a 2, or maybe maintaining distance as a 10, or maybe maintaining distance as a 1000, or maybe maintaining distance as a 2000 centimeter. But so many, so many, so many parallel lines you will be able to draw, right, Manvi?
Yes.
Okay, so this is a set of infinite line. How many such lines are there? Line L is there, M is there, N is there, P is there, Q is there, R is there, and so many more, so many more can be there. So infinite. Okay, let's do the next one. The set of letters in an English alphabet, that is limited. Okay, that is limited. Letters A, B, C, D, E, F, G, H. Okay, that is finite, right, Manvi?
Yes, ma'am.
Can you tell me what about number three?
That's also fine. Infinite.
The set
No.
of numbers which are multiple of five. Yeah,
Yeah.
multiple of five means, yeah, the five, one times five, two times 10, three times. Okay, it can keep on going and keep on going and keep on going. Okay, we also say multiple means table, but table we you learn till 10 only, 5, 10 times 50. But table is not limited till 10, it can go beyond 10. Okay, for just calculation purpose, you learn it till 10, right?
Yes, ma'am.
The set of animals living on the earth.
Is it finite?
Yeah, it is finite. We can, okay, whatever be the number, but that we can count it.
But then there are so many animals that we don't know.
We don't know, but if we will do a survey, okay, for, okay, maybe for my, the how the population counting and everything just happens. Okay, we all have to go to maybe a certain ID of with our proper ID. Okay, we go once in a while to that government office, and there they have all the data that in our family how many members are there. Okay, and they have all the data feeded in the software. So in each region they know that in this region these are the number of people, in that region these are the number of people, in that region. Okay, actually this is really broad, really broad. But if we will take this much, it's okay, and we'll give it to government official that you have to count here. Another one, give it to government official, you have to count here. This much reason, you have to count here. This much reason, you have to count here. And then everyone will feed the data in the software. Then at last we will be able to see what is the final number, right?
Yeah.
Okay, this only happens when we are talking about the population of our country is approximately this much. Okay, so this only happens for a certain district. Okay, they do the survey and they just keep the track that in my region these are the number of people. I have counted all the infants, all the toddlers, all the person, elderly person, everyone. Okay, and they feed the data. Another region they feed the data, another region they feed the data, and hence we get that this is the population, right? So small, small,
Yeah.
small, small. Actually this happens in all the area. If you want to do best in your final exam, okay, you have to give a small, 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 small effort from now only. Okay, whatever test is going on in your school, whatever exam is going on in your school, here if you will give any test, any exam, anything, if each one, even if it's just for 5 marks, okay, it's just for 5 marks, or maybe just for 2 marks, or maybe no marks, just revision. If each one you will be doing seriously, then automatically till the last your performance will be much more better and it will be best version, right?
Yeah.
Okay, that's what happened. We just, if we will just break our task in a smaller part, we will be able to count the number of animal in the on the earth, right?
Yeah.
Okay. Yeah, that is really tedious. That is really tedious, but it is still, it is countable. The set of circle passing through the origin. The set of circle passing through the origin. Origin in coordinate geometry chapter, you understand this point is called origin, right?
Yeah.
Here the coordinate is 0, 0, right?
Yeah.
How many? The set of circle passing through the origin. How many circles we can draw passing through the origin? Manvi,
Um.
passing through the origin.
Is
Even if
infinite.
figure, yeah, even if my figure will look really okay, not that really so many circles all together, still still I am taking origin, and still I will keep on drawing and keep on drawing and keep on drawing and keep on drawing and keep on drawing. Yeah, the final figure is not looking good, but I will be able to keep on drawing by taking any radius. Maybe one time I am taking radius as a 7, another time I am taking radius as a 6 or whatever, or maybe radius as a 1, radius as a 2, radius as a 3, radius as a 4. Whatever radius is coming in my mind, I am taking it. But every time I am making sure that our circle is passing through the origin, right? So that way we
Yeah.
can draw so many circles, right?
Yeah.
Okay, so yeah, let's continue. Now, equality of two sets. Okay, so if we are talking about equality of sets, we just have to check the number over here and the elements over here and the elements over there are same or not. Doesn't matter if it is written in the same manner. For example, we are having ABC over here, and here we are having CAB. So these two are same, because here A, there A, here B, there B, here C, there C. These two are exactly equal set. Okay, so we just have to match the element. Order is not important. Order over here is not important while writing the set. And yeah, we will also try not to repeat anything. Okay, repetition is not allowed when you are listing down the element. Even if in your collection repetition is there, okay, I'm taking the data of maybe I'm taking collecting the data of temperature, okay, in last 12 month or maybe 24-month. Each and every month, whatever was the temperature, average temperature, okay, I'm writing it. So many times I'll find that one day there was 10 degrees centigrade, okay, maybe another day, okay, again there was 10 degree, another day again there was 10 degree, right? We can have
Yeah.
collection like this. But while listing down in a set, I'll be writing it only one time then, and then another numbers. Getting it?
Yeah.
Okay. So yeah, we just have to check whether the given sets A and B are same or not. Exactly same or not. So let's see the first one. Here A, there A. Here B, there B. Here C, there C. Here D, there D. And we are done. A is equals to B. These two sets are exactly same with each other. Got it?
Yeah, I understood.
Okay. Here 4, there 4. Here 8, there 8. Here 12, there 2. No 12. So A and B are not same. It's not equal. Not equal. Okay. Getting it, Manvi?
Yeah.
Now, just to increase the level of the question, okay, you can see here the question is given. One of the set is given in roster form, another is given in set builder form. So 2 is there, 4 is there, 6 is there, 8 is there, 10 is there. Next one, it's given in set builder form. Let's write it properly first. Set B is the set of all x. All x. X is a positive even integer. Okay, positive means starts from 0. Even integer. Okay, so even number 2, 4, okay, 6. And x is smaller than or equals to 10. If you are comfortable with inequality, then you will understand x can be 10 or is smaller than 10. Right, Manvi?
Yes.
Okay, now we have to match these two are exactly same or not. Here 2, there 2. Here 4, there 4. Here 6, there 6. Here 8, there 8. Here 10, there 10. Yeah, these two are exactly same. A and B are same. Okay. Next, again, one of them is given in set builder form, another in roster form. Let's write it. A is set of all x such that x is a multiple of 10. Now multiple of 10 is infinite, okay? 10. 1 times 10, then 2 times 20, then 3 times 30, then 4 times 40, then 5 times 50, then 6 times 60. These are the multiple, or maybe these are the table of 10, right?
Yeah.
Let's match it. A10, B10, A20, B20, A30. Okay, that is also having 30. But what about this 15? What about this 25? This type of number will not come in multiple of 10, right?
Yeah.
So A and B are not equal. A is not equal to B. Okay, now sometime our question will also be given in this manner. In class 10 quadratic equation, you have done the complete chapter. Now your set may look like this, that set of all x, which is the solution of this equation. Okay, set of all x such that x is the solution of this one. So first you have to find the solution from here. In class 10 quadratic equation chapter you have done, you can try doing splitting the middle term, or maybe you can use quadratic formula, whatever you want you can use it. If sometime splitting the middle term is not working, then please use quadratic formula. Okay, because the same type of question, Manvi, if we will just change this equation and will make it quite confusing equation by having the understanding that a student already know quadratic formula, that x equals to minus b plus minus under root b square minus 4ac by 2a. They know that if splitting the middle term doesn't work, then this formula they can use, right, Manvi?
Yeah.
Okay, so please keep it in mind. This time we will be using splitting the middle term because that is easy. But sometime you have to use this way also. Okay, let's split the middle term and let's find the x value. We'll be having x square 6, 3 2 times 6, right, Manvi?
Yes, ma'am.
Okay, so you will be able to find the x value from here. It will be x plus 3, it will be x plus 2. X value we are getting as a minus 3, minus 2. And here we can see x value is just 2, just 3. So these two sets are not equal, right?
Yeah.
Okay. Now follow, you know, even though we are having double L over here, we will be writing in our set a single L. F will be there, yeah, O will be there, a single L will be there, and W will be there. Okay. A curly bracket close. Similarly, we can see the next one is the letter ULF. Okay, same alphabets we are having. So yeah, these two are equal, right?
Yes, ma'am.
Okay, now the next one. From the set given below, select equal set. Okay, equal means you already understand. We just have to match the elements over here. So yeah, you'll be able to do this one, right, Manvi?
Yeah, I can.
Okay. We just have to see which are equal with each other. If you want to take it quick, let me take it. Here 2, here 4. We can see where 2 we are having. Okay. So you can see here 2, here 4. But 8 is not there. So A and B are not equal. What about A and C? So 2 and 4 is not there. A and C are not equal. Okay. Any other set? We can see no set is equal with A. Can you see?
Yeah.
Okay. Similarly, if we will be taking B, we will be checking B is same with C or not. No. B is same with D or not. So 1 is there also 1. 2 is there also 2. 3 is there also 3, and 4 is there. So B and D are equal. Okay. So one by one, we are checking with each and every set. Here C, 4, 8, 12, 14. We can see. Okay. We will be checking C with D. Okay. C with E, C with F. Previous one we will not be checking because already we have checked. Okay, once we had taken A, then we had already checked. So C is not equal with any of them. You can see D already we matched that it was same with B. Then E, this one and this one is exactly same. Okay, E and G. Element can be here and there. Order is not important. While writing the set, order is not important. E and G are same. Okay, and F and H, nothing. So these two are only equal with each other. right, Manvi?
Yes, ma'am.
Now subset from here, actually, okay, actual these were only the basics of the set, that how to represent the set, what are the types of the set. Equal set means what, infinite set means what, okay, finite set means what, okay, and null set, empty set means what. So these were just the basics of set. Now subset, from here the actual, okay, the main discussion will start from here, that what is the meaning of subset. So subset means, yes,
Sorry, I'm it was my computer.
no worries. Do you want to say anything? Do you know what is subset of any set?
Yeah, it's like it comes under a set basically.
Yeah. Okay. If you are having a set, if you are having a set A, that is 1, 2, 3, 4, 5. If you are having a set B, that is 2, 4. Then we can say B is the subset of A, right?
Yeah.
Okay. Why? Because the element of B is already present in A. Okay. This 2 is 2 belongs to B, and the same 2 belongs to A as well. Similarly, this 4 belongs to B, and the same 4 belongs to A as well. If each and every element is already present in A, then we can say B is the subset of A, right, Manvi? We can
Yes.
write this way also, that B